Hi and welcome to the lesson on random variables, which is a part of our probability distributions unit. So for this one, make sure you've got your, this is the first slide, make sure you've got your graphing calculator because you'll be using that a fair bit, especially for the warm-up. So please make sure to have it with you. If you don't have it, please pause, go grab it now because you'll be using it a lot. So here's the first warm-up. Find the mean, median and mode by hand. So practicing a bit of stats warm-up. Feel free to pause and try the warm-up yourself first and then just skip ahead to the end and then unpause and check your answers. So find the mean, median and mode. I'm going to do it by hand first and then with calculator. So we've got our x values in the left column and we've got our frequencies in the right column. So remember what you need to do is work out the fx column. So the fx column is worked out using 4 times 10, 5 times 6, 6 times 4, etc. And then the mean will be the total of the fx column divided by the total frequency. So mean is the total fx divided by the total frequency, which is 5.57 to 3 significant figures in this case. Then the median remember will be located its middle value. So we don't have it written out as a big list of numbers, instead we have it in a frequency table. So we use the fact that the median will be located in the n+1/2th position. So the middle position, the total frequency is 30, so n is 30. So the middle position will be in 30 plus 1/2, which is 31/2, which is the 15.5th position. So then you've got to count up to the 15.5th position, or you can think it will be the average of the 15th and the 16th positions if it's the 15.5th position. So counting down the frequency column, so the first 10 values are 4, and then the next 6 values are 5. So the 15th and 16th positions will be a 5. So counting down the frequency column, the median equals 5. And then the mode is the most popular value. So which one has the highest frequency? Highest frequency is 4. So the graphing calculator, remember, so this is if it was a non-calc paper. If it was a calc paper, you could just plug it into your graphing calculator. So remember you would go stat, edit. If you haven't cleared your L1, clear L1 by going up here, clear and enter. And then you enter in your data. So you would enter in the data, which is 4, 5, 6, 7, 8. So 4, 5, 6, 7, 8. Practice doing this now if you haven't already. Enter in your frequencies, 10, 6, 4, 7, 3. It's really easy to mistype, so you should go back and check that you've typed in the right things. And then you would go stat, calc, and it's one variable statistic because it's mean and median. The mode you can't find on the calculator. You just have to do that one by hand. 1 bar stats. And so it's a frequency column table. So if it was just a list of numbers, we would just say L1. But because it's a frequency column, L1 has got the X values and the frequencies are in L2. So remember to do L2, it's here, so you need to press second 2 to make L2 happen. Then just be aware, L2 is going to be stuck in there. So if later on you then need to do a calculation when there is no frequency column, it's just a list, you'd have to delete off the L2, so don't forget that. Calculate, and just showing you that the mean is the top number, which confirms that 5.57 or 5.56 with the recurring on the 6 is fine too. 5.57, and you'd need to scroll down to get the median. See the standard deviation is here as well to practice that. The median and the quartiles are here, the lower quartile, the upper quartile. Here's the median. The median is 5. So just confirming that value there. So don't forget how to use your calculator too. So that's what I just did there, basically. So make notes. Oh, and the standard deviation, find the mean and the standard deviation, of these values. So it's a little bit different this time because you've got different values here. So you'd need to put in, so remember you would have to go stat, edit. Now I've already got some rubbish in my column, so go up to here and press clear, enter. Don't press delete, because that deletes the columns. Go clear, enter. And you've got some new columns. What needs to go in here is the midpoints. So we need the midpoint. So what's the midpoint of 0 and 5? If you're not sure, find the average of 0 and 5. 0 plus 5 over 2 is 2.5. So 2.5 is your midpoint. What's the midpoint of 5 and 10? 10 plus 5 is 15. 15 divided by 2 is 7.5. And so on. Midpoint of 10 and 15, 12.5. Don't assume it's always going up in terms of it's the next one along. It could suddenly jump up to 20 to 25. So just be careful of that. 17.5, the next one. What would be the next midpoint? It would be 22.5. Just double check you've got all those right. Enter in your frequencies. Again, feel free to pause and just do this yourself. Oh dear, they were the same ones. I should have just left them. A chance they happen to be the same ones. 4, 7, I think to make it easy to do. And then what do you press again? You go stat. So the midpoint's actually already here. So stat, calculate, so go across to calculate. That's a one variable stat. So it is the frequency column, so we've got to tell them L1 is our midpoints, and L2 has got all our frequencies in it. Because it's a frequency table, calculate. Here's our mean, 10.3 recurring. You could have written instead of 10.3, so feel free to change it to 10.3 recurring if you prefer, an exact value. And the standard deviation is this one here, so not the SX. When it just wants a regular standard deviation, it wants this one here, 7.03. 7.03 for that one, for 3 sig figs. So now moving on to the actual lesson, which is on random variables. So discrete random variables, what on earth are they? A random variable represents a number represents in number form the possible outcomes which could occur for some random experiment. So we're talking about probability here. So a discrete random variable, well, a random variable is just a general term, whereas a discrete random variable has possible values. Because remember, discrete numbers take on particular values, like 1, 2, 3, 4, or so on. So it has possible values x1, x2, x3, and so on. For example, the number of houses in your suburb which have a power safety switch. So the number of houses, you would get 1, 2, 3, 4, 5 houses. So take on discrete values. The number of new bicycles sold each year by a bicycle store. The number of defective light bulbs in the purchase order of a city store. So the number of something takes on discrete values because it's 1, 2, 3, 4, 5, 6. That's what a discrete random variable is, as opposed to a continuous random variable. Because remember, continuous data takes on all possible values like height, weight, air pressure, temperature. It's measured by an instrument, kind of generally it takes on continuous values because it goes up continuously. Continuous random variable x has all possible values in some interval on the number line. For example, the heights of men, you measure it with a ruler or a measuring tape, could lie anywhere between 50 and 250 centimetres. It's not like it goes up like 51, 52, 53. The volume is another example of water in a rainwater tank during a given month. An extra thing to note, a discrete random variable involves a count. So you count the number of houses, you count the number of bicycles, you count the number of defective light bulbs. Whereas a continuous random variable, you tend to measure with an instrument, like a thermometer, a measuring tape, a measuring cylinder, that kind of thing. Okay, so try these out. Feel free to pause these. And so I'd say pause the video now and try classifying the following random variables as either continuous or discrete. You can use a C for continuous and a D for discrete. So pause and then check your answers. Okay, so hopefully you've paused and you've worked it out yourself. Now see how you went. Okay, quantity of fat in a lamb chop, continuous, because you measure how much fat. You weigh it using a scale in science. So how many grams or milligrams or that kind of thing. Mark out of 50, you count the marks on a test. So you count the marks on a test, so that's discrete. Weight you measure with a weighing scale of a 17-year-old student. Also quantity of fat, you could think of it as being the volume of fat as well. Volume of water you measure with a measuring cylinder. The number of trout in a lake you would count, so it's discrete. The number of hairs on a cat you count, so it's discrete. Length of hairs you measure with an instrument, with a ruler. Height of a skyscraper you would measure with some kind of height measuring device for skyscrapers, so continuous. So D for discrete, C for continuous. And now let's move on. How does this relate to probability distributions? So for any random variable, there is a probability distribution associated with it. So for example, if you're flipping a coin, so first throw you've got head, tail. Second throw, head, tail, head, tail. So the outcomes of throwing 2 coins, you've got head, 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 tail, tail, head, tail, tail. So the number of heads, 2, 1, 1, 0. So for example, when tossing 2 coins, a random variable could be 0 for heads, 1 head or 2 heads. So i.e. x equals 0, 1 or 2, meaning the number of heads. The associated probability distribution being 1 over 4. So 1 out of 4, like 1 in 4 outcome. So the probability of getting 1 head is 1 in 2, because there's 1 out of 4 plus 1 out of 4, which is 1/4 plus 1/4 is a half, and so on. Probability of there being 2 heads is 1 in 4. There's a 1 in 4 chance of being 2 heads. Probability of no heads would be this outcome, which is 1 in 4 as well. Confusing, eh? So the P stands for the probability of this many heads. So feel free to take extra notes if you need to. So if you were to graph that, you kind of get this kind of distribution, don't you? So you start to notice things like normal distributions, binomial distributions, kind of follow these kind of bell curvy kind of shapes. You can do it as a bar graph as well. So you've got the probability here, no heads, 1 head and 2 heads, because there was 2 outcomes for 1 head. You start to get these kind of like nice kind of shapes. If you define the random variable as the number of heads obtained, you can summarize the information in a table, which is just basically these things in a table, and then it's graphed. So probability, what does that mean? Probability x equals lowercase x. Is the probability that the number of heads is x. So the probability that the number of heads is 0 is that. Probability that the number of heads is 1 is that. Probability that the number of heads is 2 is that. So this is kind of getting used to the terminology and the notation. You start to see this kind of notation pop up a bit. So we'll write the probability big X equals lowercase x as a probability of x. Sometimes you'll see in some textbooks big P for probability. Sometimes you see lowercase p for probability. So just be aware of the different types of notation that are possible. So for each random variable, there's a probability distribution. The probability of any given event. Probability of a thing happening lies between 0 and 1. Because remember, probabilities, if you're talking about have them in decimals, you can have 0 all the way up to 1. If you write probabilities as percents, it's 0 up to 100%. So probabilities basically can lie between 0 and 1. So probability of something being absolutely certain that's going to happen is 1. Probability of it being impossible is 0, and in between, everything in between is possible as well. So therefore, remembering this means the sum of the probabilities equals 1. So say for example, if you add up all the probabilities, like on the previous slide, if you added up all these probabilities, they have to add up to 1. So this symbol means the sum of all the probabilities must add up to 1, i.e. probability of 1 plus 2 plus 3 up until probability of n. So n is 1. Probability distribution of a discrete random variable can be given in table form, like we did on the previous page, in graphical form, and in function form, and provides us all with all the possible values of the variable and the probability of the occurrence of each variable, like on the previous page with the tables in the graphing form. So now let's do an example to illustrate this. Magazine store recorded the number of magazines purchased by its customers in one day. 23% purchased 1 magazine, 38% purchased 2, 21% purchased 3, and 13% purchased 4, 5% purchased 5. What is the random variable? So the random variable, x, is the number of magazines sold in this case, because I recorded the number of magazines sold. So the different values that can take on, according to this one, is 1, 2, 3, 4, and 5. So that's why we'll put x equals 0, 1, 2, 3, 4, or 5. Next question, make a random variable probability table. So put your x values in the top and put the probabilities, probably in decimal form, as opposed to percentage form, underneath. So your outcomes are 0, 1, 2, 3, 4, 5 magazines sold. The probabilities, according to this, are, according to this, these all add up to 100%, so there's no chance that they sold none. So 23% is 0.23, 38% is that, 21% is that, 13% is that, and so on. So we've made a random probability table, so I've got P of I and X of I. And then graph the probability distribution. So if you were to, this would be your y-axis, this would be your x-axis. Just plot them like that. So you kind of get these kind of vague bell-shaped curves. This one's a bit skewed, that's okay. You generally get these kind of like bell-shaped style curves. That's what we mean by probability distribution. So we've got probability here, 0 is 0, the highest one was this one here, 2 goes up to 0.38, and so on. Next question along. For each of these examples, draw a table of possible values of x together with the associated probability. So similar to, basically going to make a table similar to what we did here. And here's the example this time. A box contains 2 red marbles, 6 green marbles. 2 marbles are chosen at random with replacements. So after you pick out the first marble, you replace it before you pick out the next marble. And next is the number of green marbles obtained. So what are the outcomes going to be? That's what you need to think. So the types is only red marbles and there's green marbles. So if you're pulling out 2 marbles, you could get 2 red marbles, that's possible. You could get 2 green marbles. You can also get a red followed by a green, or you could get a green followed by a red. So there's going to be 4 different outcomes. So marble 1, marble 2. It's okay if you don't want to split, you could just write RR, RG, GR, GG. So we need, and here it says X is the number of green marbles obtained, not the red marbles. So number of green marbles in this case is 0, 1, 1, 2. Work out the probabilities of each of those. Probability of a red followed by a red is like 2/8 times 2/8, so 1/16, because there was 2 red marbles, and it's with replacement, so the denominator doesn't drop. And red green, 2/8 by 6/8, multiply this, multiply that, you get that. When you simplify this, 2 times 6 is 12, 8 times 8 is 64. They can both be divided by 4, so that simplifies. Same thing, you got 6/8 times 2/8, same thing simplifies. Green, you get 6/8 by 6/8, which is 36 over 64. You can divide the top and bottom by 4. So multiply the probabilities. This is a bit of a review of earlier basic probability. And then, so that's a rough working out. Put into, this is the actual answer though, put it into a nice table. So your outcomes are 0, 1, or 2. So x could be 0, 1, or 2. Probability that x equals x is 1 over 16. 6 over 16, because you've got to add these 2 together. 9 over 16. One thing to note, feel free to add any extra little notes you need to. Notice that 1/16 plus 6/16 plus 9/16 equals 1. Because that's the case, all the probabilities must add up to 1. Which shows that all possible combinations have been considered for the random variable x. Fabulous. Let's continue on this example. A fair die has been labelled 1, 1, 1, 2, 3, 3. And x is the score when the dice is thrown. So make a table for that. What are all the outcomes that you could possibly get? You could only get a 1 or a 2 or a 3 according to this dice. So probability of a 1 is 3 out of 6, probability of a 2 is 1 out of 6, probability of a 3 is 2 out of 6, which really should be written as 1/3. So next one, 2 fair dice are thrown, and x is the difference between the highest score and the lowest score. So here they're not talking about this dice, they're talking about a regular 1 to 6 dice. So if you've got 2 dice, you've got 1 to 6, first dice, you've got 1 to 6, 1 to 6, so there's 36 possible outcomes when you roll 2 dice. So therefore, 36 possible outcomes. So yeah, the probability distribution is summarized as above. Oh, sorry, yeah. What are we talking about? Why is it 0, 1, 2, 3, 4, 5? Because x is the difference between the highest score and the lowest score. So 6 minus 1 is the highest score you can get. So that's why the highest score is a 5. But you could do the lowest score is 0 because you could get 5 minus 5, for example, or 2 minus 2. So the difference is because it says x is the difference between the highest and the lowest score. So the only possible values are 0, 1, 2, 3, 4, 5. And then you unfortunately have to work those out. And then that's quite painful. But that's what the answers would be. Moving on from there because that takes ages. Okay, expectation. Consider the following problem. A die is to be rolled 120 times. So the experiment's repeated 120 times. On how many occasions would you expect, that's the important word, expect, the result to be a 6? So it might seem like a pretty obvious question, but how do you formally answer it? In order to answer this question, we must first consider all the possible outcomes of rolling the dice. So it's just 1, 2, 3, 4, 5, 6. All of these are equally likely to occur. Therefore, we expect 1/6 to be the probability of it landing on a 6. And so basically, to work out you repeat that rolling of the dice 120 times, how many times would you expect to see a 6? You would expect it to be 1/6 of those times you would see a 6. So basically, you just do 1/6. What's 1/6? You might want to write this out. 1/6 times 120, you get 20 is your answer. 1/6 of 120 is 20 times. So the answer is 20. So we expect 20 of the 120 rolls to yield a 6. So the answer is 20. So continuing on with this idea of expectation, the mean value of the random variable x is called the expected value of x and is written e of x. So this is some more notation. The expected value of x, e of x, is the sum of x multiplied by the probability of x. So in the formula booklet, it's given to you as this. The e to the x equals mu, which is the sum of x times the probability that x equals x. Let's see this in action so you can understand it a bit better. A fair coin is thrown twice, and x is the number of heads. Find e of x. So what is e of x again? The expected value of x. So what do we need to do? So you're throwing 2 coins. So again, you've got a table of 4 outcomes. First 3, you've got tail, 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 head, head, tail, head, head. And here they've defined it as being the number of heads. So the number of heads, you get 0, 1, 1, 2. Probability is the same as before. It's a 1 in 4 chance of each of those. So to turn it into a table, you've got an option of 0, 1, or 2 as being your x, 1/4. These two add to give you a half. A quarter plus a quarter is a half, and 1/4. Therefore, the expected probability, find e to the x, is the sum of x times the probability of x. What do we mean by that? So what you've got to do is, so this number here is x times its probability. So notice we did this times this, plus this times this, plus this times this. So the expected mean value is what that we're finding is 1 in that case. So that particular answer happened to equal 1. Let's do another example where it might be a bit of a different outcome. So it doesn't always equal 1, by the way. So let's do the expected number of heads is 1. So let's try a different one, or you might not get an answer of 1. The random variable x can only take the values 1, 2, and 3. Given that the values of 3 is twice as likely as each of the values of 1 and 2, that can help you to work out the probabilities, and the values of 1 and 2 are equally likely. Draw a table of possible values with p of x equals x. Okay, so p of x equals 1 equal p of x equals 2. Because of this bit, they're equally likely. And P of x equals 3 must be 2 times that probability because it's twice as likely. Find the table of possible values are shown on the right. So our possible values are 1, 2, and 3 for x. So you could think of that as being P, P, and 2P. We don't know what those probabilities are at this point. But we do know that all the probabilities must add up to 1. So you could therefore work out what P is. So if all the probabilities add up to 1, 2P plus P plus 2P must equal 1. So therefore 4P equals 1. So P must be 1 over 4. So that means that when you sub that in, so a quarter, and a half. And that makes sense then. And that's because, remember, all the probabilities must add up to 1. This means that we were able to solve for P. Then determine the expectation of x. So remember, expectation of x, you do that times that, plus that times that, plus that times that, because we're working at what e to the x is, so 1 times that, plus 1, 2 times that, plus 2 times that. It doesn't equal a half this time, because you've got a quarter, plus a half, plus 3 halves. So a quarter plus a half is 3 quarters. 3 quarters plus 3 halves is the same as 3 quarters plus 6 quarters, which is, 9 quarters. Then going on, some more examples. The random variable x has a probability distribution given by probability of x, a bit more obscure this time, equals x over k. So the values of x can only be 1, 2, 3, 4. Find the value of the constant k. This might be a little bit tricky this time. But they did tell us that in general, the probability is x divided by k. And that might help us to work it out because you know these all have to add up to 1. So the outcomes are 1, 2, 3, 4. The probabilities are whatever the x value is divided by k according to this. So that one must be 2 over k, that one must be 3 over k, 4 over k. You know these all must add up to 1. So set that equation up. So you know that all of that must add up to 1. And it's got a common denominator. So because you've got a common denominator, you just add the numerators. So 1 plus 2 plus 3 plus 4 gives you 10 over k equals 1. So what does k have to equal? Rearranging, 10 equals 1k. So k equals 10. Because 10 divided by 10 equals 1. And then, so now you know that that's 10. So if k is 10, then that's 1/10, 2/10, 3/10, 4/10 is the probability. So to calculate e of x, it's 1 times 1/10, plus 2 times 2/10, plus 3 times 3/10, plus 4 times 4/10, which we can show here. Work them all out and add them together. You'll get 1/10, plus 4/10, plus 9/10, plus 16/10. Add that all up together, and you'll get 30 over 10, which simplifies to 3. Bravo. And that's the end of the lesson. Thank you.